All right, guys, so we are doing these notes in class, but I'm going to put them up here just in case anyone needs any help. So this is our trig day, and trig works in right triangles. So we're going to talk about the ratios of the lengths of sides of a right triangle that are related to the acute angles, not the 90-degree triangle. So there's three basic trig ratios, and there are more, but these are the three that we normally know, and they're on your calculator. We have sine, S-I-N-E, which was abbreviated S-I-N, cosine, which is abbreviated C-O-S, and tangent, which is abbreviated TAN. So those are all buttons on your calculator. And what these stand for is the relationship between certain angles. So if I have a triangle right here, and I'm going to zoom in, it's a right triangle, and say I have this angle theta, okay? Well, I can relate the sides to that angle, meaning I have the hypotenuse, which is always the same across from the 90. The angle that is across from the angle that they give us, or the side across from the angle, is our opposite side, and the side that's next to our angle is the adjacent side. So we're going to use those sides to create some ratios. So the definition of sine is when you're going to take the opposite side and divide it by the hypotenuse. Okay, basically what they're going to look like is you'll have the sine of some angle, and I'm going to use this symbol theta to represent the angle, equals the opposite side over the hypotenuse, and it'll make more sense in just a second. The cosine is the adjacent side over the hypotenuse. So if we look at that one, it's cosine of theta equals the adjacent over the hypotenuse. And then tangent is the opposite side over the adjacent. I'm just going to abbreviate those, meaning that the tangent of our angle is opposite over adjacent. So basically with this, all we need is one side of any right triangle, not just our special rights, and we can find the other two sides. So let's look at this problem down here. It says find the sine, cosine, and tangent of A. And then we're going to find the same thing for B, and you can kind of see how they're related. So I'm going to circle my A, because that's the angle I'm using, and I'm going to label my sides based on that angle. So the 5 would be the opposite side, the 12 would be the adjacent, and of course 13 would be the hypotenuse. So I'm going to sine of A being my angle. Well, sine is opposite over hypotenuse. The opposite side is 5. The hypotenuse is 13. Cosine of A. Cosine is adjacent over hypotenuse, which would be 12 over 13. Then we have tangent of A, which is our opposite over adjacent. That's going to be 5 over 12. Now we also need to do this for B. So I'm going to change colors here because now things change a little bit. If I'm talking about B, then 12 turns into the opposite. 5 is now the adjacent, but 13 is still the hypotenuse. So I'm going to have sine of B, cosine of B, and tangent of B. But it's basically the same thing I did up there, just with slightly different numbers. So sine is opposite over hypotenuse, so the blue would be 12 over 13. Cosine is adjacent over hypotenuse, that would be 5 over 13. And then the tangent would be opposite over adjacent, which in this case would be 12 over 13. Or 12 over 5, I'm sorry. And you can kind of see how these are related. The sine of B and the cosine of A are the same. The cosine of B and the sine of A are the same. And then the tangents are reciprocals of each other. So let's flip the page, get another one. So it's the same basic question, except for that the triangle is turned, so you have to be careful when you're looking at the hypotenuse. So I'm going to go ahead and change this one. I'm going to do S first. So here's my S. That makes 3 opposite, 4 adjacent, and of course 5 is my hypotenuse. So I'm going to find sine of S, cosine of S, and tangent of S. Sine is opposite over hypotenuse, which would be 3 over 5. Cosine is adjacent over hypotenuse, which would be 4 over 5. And tangent is opposite over adjacent, which would be 3 over 4. Now I'm going to switch colors because now we're trading to this angle being E, which means my opposite and adjacent switch. So now 4 is the opposite, 3 is the adjacent, but 5 is still my hypotenuse. So I have sine of E, cosine of E, and tangent of E. So sine of E, opposite over hypotenuse, would be 4/5 this time. Cosine is adjacent over hypotenuse, which would be 3/5 this time. and then tangent is opposite over adjacent, which in this case would be the reciprocal of the other one, which is 4/3. So those are not very complicated, guys, but you have to be careful and label them right. It's easier if you use two colors, but I know a lot of you are going to use the pencils. Now, it says use trigonometric tables to do these. We're not going to use tables. We're just going to use our calculator, but there's something really important you have to do first. Everything we're talking about is in degrees. Your calculator's default mode is radians, which is another way to talk about these. So you're going to have to put your calculator in degree mode. If you go to mode, it's on the top row. You'll see radians and degrees. You need to highlight degrees. If you don't, you're going to get completely different answers. So basically, this is just putting it in the calculator. So if it was in the right mode and you put in cosine of 41, you should get a 0.755. That's a bit rounded. And if you put in sine of 78, you should get 0.978. So put those in your calculator. Make sure you get those numbers. If you don't, check the mode, because that's what it always goes back to. So this leads us to example 4, which is actually kind of using some trig here. We don't know certain sides, and they're going to give us one side, and we need to find the side that they ask. So the first thing you need to do in any of these is pick an angle. Okay? Now, you could pick 69 or 21. I'm going to go ahead and put 69, which means this side over here would be my opposite. The side I'm looking for is my adjacent, and the side they gave me is my hypotenuse. So you need to think about the side you know and the side you want to find. In our case, we need to find A, and we know H. So A and H go with cosine, because cosine's adjacent over hypotenuse. So I'm going to put the cosine of our angle equals adjacent, which is x, over the hypotenuse, which is 9. Now that is our equation. So I'm going to write that right here. Cosine of 69 is x over 9. Now we need to solve it. Now we have a fraction on the right side, and I can get rid of fractions by multiplying by the denominator. Now remember, cosine of 69 is just a number. It's like saying x, so I can multiply it by 9. I get 9 cosine of 69 equals x, and then you can put that in your calculator. Hit 9 cosine 69 and press enter. If you did it right, you should have got 3.23, and of course that's rounded a little bit. So you might try the next one on your own. I'll kind of give you a setup. I decided to choose 53, but of course you could choose 37. Well, if I choose 53, it's given me my hypotenuse, and it gave me the opposite side. So O's and H's go with sine. So I have sine of 53 equals the opposite side, x, over the hypotenuse, 13. There's our equation. But the solution is working it the same way as we did the last time. We multiply both sides by the denominator, 13, and I get 13 sine of 53 equals x. And then, of course, you can put that in your calculator, 13 sine 53. And if you're in degree mode, you should get the length of that side as 10.38. So it's a little bit confusing. Just work it out, and if you have questions, just come ask me. We are doing this one in class, so if you're watching this, you probably are out on this Monday. Let's go to the back page. Now they're making us find the two missing sides, but the thing is, the work is pretty much the same. They only give us one angle. Of course, we could find the other one, but I think using that one's the easiest. So I'm going to set up both of my equations. The x in this one is my hypotenuse, the y is my opposite, and the a is my adjacent. So I'm going to set it up this way. I'm going to find x first. I know a. I'm trying to find h. That means I'm going to use cosine of 54 equals a, which is 8, over x, which is our hypotenuse. Now I can use that as my equation down here. Cosine 54 equals 8 over x. Now we haven't had one like this. This time x is in the denominator, but we can kind of work it the same way. I'm going to multiply both sides by x.